6, quiz review. This is a very thorough review. So we start, graph each function. If we look down a little bit, you can see the whole concept in the first couple questions is wondering if you've been listening to this whole thing, where we have an exponential function, and this, if b is greater than 1, is growth. So it's going to look like this. If b is less than 1, not negative, just like a fraction, like 1/2 or 0.3, hint, hint, we're going to have exponential decay, which looks like this. Now don't forget, our locator point is huge, because if x is 0, anything to the 0 power is 1, so that kind of disappears. So our point would be y equals a, whatever a is, whatever's in that position. Now these first two problems are a little sneaky because they hide letter a. There's a 1 there. So it's 1 times 0.3 to the x power. This one is, again, a little sneaky. 1 times 3 to the x. So there's my a, there's my b, there's my a, there's my b. So you have to be aware of that sneaky little a if it's not jumping out at you. A normal looking one might look like this, where you can see this is a. But when they don't give it to you, you have to know it's a 1. There's a warm-up. Alright, so I drew in these two little graphs for you. And if you have to, start with the basics. Let x be 0. So that'd be 0.3 to the 0 power, which is 1. 1 times 1 is 1. So there's that locator point, 0, 1. And like this. Alright, we'll talk about all these key features in a minute, but let's get this one drawn out. This time, if we let x be 0, that's 3 to the 0 power, which is 1. 1 times 1 is 1. So there's our locator point again. Growth should be like this. It would just go up a little bit faster like that. So I know that's a lot to get started with, but this one here is exponential growth, and it would look like that. Now the asymptotes, well, let's go ahead and go with, in order, domain. And it also goes to the right forever, so that's infinity, all real numbers. Now the same thing here happens, negative infinity to positive infinity, because it goes left forever, it goes right forever. Now how about range? Well, range, you start with how low it goes. I put parentheses. So on this, what's the lowest it gets? Well, it never touches, but it tries to get down to 0. That's why we have to have parentheses, not a bracket. And then it just goes up forever. And this range would be the same. Tries to get down. So the only intercepts are right here. So that'd be 0, 1, and this one would be 0, 1. So intercepts, intercepts, and then good old end behavior. Well, that means on this one, what happens? Well, this just means your roller coaster guy is on this roller coaster going to the left. It would go up. End behavior is actually talking range. So ultimately, how low or high does it go? Well, as it's infinity, because that's where it's going, up, up, up. But as it goes to the right, the end, so my roller coaster is going this way forever. What's the end behavior? Well, it's trying to get to 0. So the end behavior for this one would be 0. Would never touch it, but it's approaching 0. This one, little coaster, would this be going up or going down? Well, it's going down and it's approaching 0. So my answer to this one would be 0. But as my roller coaster goes to the right, this way, the wheels are stuck on the roller coaster, so it would be going up forever. So my end for those two problems. But this says without graphing, determine whether it represents exponential growth. Remember, that's b is greater than 1. Decay, that's b is less. So this is decay. Now what's the y-intercept? Well, that's where x equals 0. So if I put a 0 in there, 1/3 to the 0 power is 1. So my a is my y-intercept. So it's 0.9. And if we let x equal 0 to find our intercept, 1.75 to the 0 power is 1. 1 times 20, y would equal 20. So 0.20 would be the intercept. All right, let's move on to number 5. Okay, number 5. Got to the formula, got the highlighter out already. Now we just need to read it. Write an exponential function. Remember, f of x equals a times b to the x is just our basic generic learning that we just and that's kind of our x. So it's the same thing as this, just with some more specifics. So a population of 1,236,000 would go here. Find the amount after the time. So this is just what we're trying to find. Population convert that to an actual number. We got to move the decimal places to the left, and it says 10 years. Now this is a calculator special. Let me grab my calculator. So I'm going to add this together and raise it to the 10th power. So 1.013 raised to the 10th power. Got to go PEMDAS. And multiply that times 1, 2, 3, 6. 1, 2, 3. Did I hit times? No. All right, so back to the drawing board. So my answer, which is that, times 1,236,023, hit enter, and it's approximately 1,406,413. I don't know if we want to round this to 0.2, because you can't really have a 2/10 of a person, but we'll round it to the 52,000 decreases. So that means 1 minus, because it's losing population, and that turns into 0.014. That's my R for 18 years. So it's going to be a little bit more challenging, not really, but by 752, 1, 2, 3, hit enter, 583,448. And there's the population. Now we're going to talk about. So this is the formula we're going to use if an investment times per year, and that's what equals n, the number of times the interest is applied to this per year. So following this formula, which is very close to this one, I use the letter A for amount. So the amount that initial the number of times it's applied, 4 times per year, and then my n pops up again there, and then 10 years. So we just got to follow PEMDAS. Divided by 4. I'm going to just add 1. And now I know this is 40. So I'm going to take my answer, raise that to the 40th power, and then I'm going to multiply that by the original investment. And there we go. Now we have a different problem. Ella invests $2,000 into an account that pays 4% annual. That means one time per year. But it's compounded continuously. That gives us a whole nother weird formula. Or when an investment compounds continuously. So if we just put things where they belong, our initial investment is $2,000. E, I'm just going to keep that in there and show you what to do with that. Give me a second. I was in too much of a hurry. Didn't write the formula down right. It's A PERT, but RT is in your exponent there. I almost screwed that up. And it says for 5 years. Now, where's this letter E? Well, don't forget the letter E is 2.71, but we can find it on our calculator right here. So I'm going to go second E. I'm going to raise that. Give me a second. Let me just go 0.04 times 5 to show you where these numbers are coming from. 0.2. So it's really, this right here is 0.2. So I need to take my calculator and again go second E, raise that to the 0.2 power, then multiply that by the original investment, and there it is, approximately $2,442.81, rounding it to the nearest penny there. All right. So this one's just questioning your basic understanding of logarithms. So this is my definition here. Log, little base, exponent, answer. So if we keep what I taught in class, you start here, go there, go there. So if we turn that into a logarithm, what's our base? 4. That's that little guy. What's our exponent? 3. Where do we put our answer? Right there. So there's logarithmic form. Now we're going to do the same thing here. Don't panic. What's our base? Our base is 6. I like to go from here to here because what's my exponent? -3. What's my answer? 1/216. Now we got to go backwards. Remember, if there's nothing here as the base, it's assumed that that's a 10. So we start here, go there, go there. We're not finding anything. We're just rewriting it. So base exponent, answer. And this one, trying to mess with you, we know that anything to the 0 power is 1. They just want us to put things where it belongs. So log, what's our base? 1,000. What's our exponent? 0. And then what's our answer? 1. This just says 1,000 to the 0 power is 1. Just following the rules. Again, not solving anything, just putting things where they belong. What's my base? 5. What's my power? 1/2. What's my answer? Square root of 5. So this is true, 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 true. But you're not finding anything. You're just putting it in different looking forms. Okay, we'll try to finish this here. Now it says evaluate. That means find your missing piece. Well, what's the missing piece? It's your exponent. So we start here, we go there, and then we go there. So 5 to the x power equals 1 over 625. Some of you are very driven by common sense, and you would just go 5 times 5 is 25, times 5 is 125, times 5 is 625. So we know that x has to be 4, but because it's in the denominator, you could just say x has to be -4. That's one way to look at it. The other way to look at it is keeping that the same. Common bases, happy places. So I'm going to go 1 over 5 to the 4th. I've just changed the way it looks. Now I'm going to bring that upstairs and go 5 to the x equals 5 to the -4. And then these would just cancel. X has to equal -4. So I don't care how you work your way through it. Either way is fine. This one's a little bit easier because if we just put in our missing piece, we realize that's our exponent. That's our answer. So base is that little 8 there. X is our exponent. And then 8 to the 5th is in that position of where our answer is. And then these disappear because common base is happy places. So x has to equal 5. Look at this one. 3 to some power is -10. Now if you were listening in class, you know this is impossible because you can't raise 3 to any power and get a negative answer. You might say, well, what about a -1? Well, that'd be 1/3, still positive. What about -2? That'd be 1/9, still positive. You can't have a negative in that spot, and you can't have a 0 either. Just FYI. Last one. Invisible 10, x. So 10 to the x power, this might be a misprint, equals 150. You haven't been taught how to find these yet. Let me tweak this just a little bit. All right, so I'm pretty sure this is a misprint because you're going to learn this later in Unit 6. So they're going to be more straightforward with you like this, stuff that works out. So I'm going to put my x in there, start here, go there. That equals 100. You could use your common sense and just say x is 2 because 10 squared is 100. Or you could, good old math, just write 100 using base 10, common bases, happy places, and then these disappear and x is 2. There you go. Now if I'm wrong about this, and you're actually expected to learn this before the quiz, we'll work it out. But I think that's a typo. There you go, guys. Reach out if you have questions. Like and subscribe. Let's go viral.